Hello everyone, welcome back to my YouTube channel. Today we are seeing class 10, science 1, chapter number 3, chemical reactions and equations. And this is the third part we are in. We had already completed first two part where we had studied about the chemical reactions, how to write them, balancing the chemical reactions. Then we studied about the types of chemical reactions, in that the different types of chemical reactions we studied. Now today we are going to see the rate of chemical reaction. It's very simple concept. When we talk about the rate of chemical reaction, means actually we are talking about how quickly or how slowly a particular reaction takes place. There are various things about the chemical reactions. Some of the chemical reactions, they are too fast. Some of the chemical reactions are very slow. Like if I am talking about the rusting of an iron, rusting of iron is not like a 1 hour process or a 2 hour process that within an hour you will get a rust on the iron article. It takes time, it consumes time. So rate of chemical reaction in this particular case will be a little slower. Means basically we talk about the time consumption to reaction to take place or to complete the reaction. That is nothing but what the rate of chemical reaction. When we talk about the rate of chemical reactions, there are the multiple factors which decides the rate of chemical reaction. So that factors we are going to see, factors affecting the rate of chemical reaction. In that, the first one what we are going to see is the nature of the reactant. Nature of the reactants are very much important. Means the materials which we are bringing in a contact for the reaction, means the reactants, that influences the rate of chemical reaction. You can see they have mentioned over here the nature of reactivity of reactants influences the rate of chemical reactions. Simply, when we talk about the nature, means the particular material, whether they are reactive to each other or not. That is important. On a reaction of both aluminium and zinc with a dilute hydrochloric acid, H2 gas is liberated and water-soluble salts of these metals are formed. However, the reaction of aluminium metal takes place faster as compared to the zinc metal. Why this one is happening? Because aluminium is having more reactivity as compared to the zinc. Aluminium is having a high reactivity. If you have studied or if you have remembered that the reactivity series of the metals, in that aluminium comes before zinc. Aluminium is a much higher reactive than the zinc, and that's why the rate of production of that H2 gas is higher when it's reacting with the aluminium. The next one what we have to study is the size of the particles of the reactant. The B part what we have to study, that is the size of the particle of the reactant. Simple example I am taking. Suppose if you have a one glass filled with the water and you are adding a crystal sugars in that and stirring it. So to dissolve that sugar in the water requires more time. If instead of that you are grinding that sugar, making it a fine powder, and then you are pouring in that glass filled with the water and stirring it, that will get dissolved faster. Means the size of the size of the particle of reactants is also playing a vital role. Smaller is a particle, faster is a reaction. Bigger is a particle, slower is a reaction. Why this is happening? Because the smaller is a particle, more surface area it's producing, or more surface area is in a reaction takes place, and that's why the reaction is faster with the smaller particles. Here they have mentioned also the rate of reaction depends upon the size of the particles of the reactant taking part in reaction. Smaller the size of the reactant particles, higher is the rate of reaction. Further, the next factor which affects the rate of reaction, that is the concentration of the reactants. The concentration of reactant is also important for the rate of reaction. Concentrated materials, concentrated acids or the alkalis, they are playing a vital role, and they are taking or they are bringing the higher rate of reactions, whereas the dilute materials, they are having a slower rate of reaction. Another is the temperature of the reaction. Temperature of the reaction is also one of the important factor. Simply, if you want to dissolve a sugar in the water, take a two types of a water, the one which is very chilled, taken out from the refrigerator, and the other side you can take a water which is slightly heated, and try to add the same amount of a sugar in both the containers. Stir them and you will find the water which was warm, in that the sugar will dissolve faster. Means higher is the temperature, faster is the rate of reaction, whereas lower temperature, the rate of reaction is a much slower. The next factor what we are having is a catalyst. Some of the reactions, they require a catalyst. The substance in whose presence the rate of chemical reaction changes without causing any chemical change to it, it's called as a catalyst. Means there are the certain materials, certain chemical compounds which are playing very vital role in completing the chemical reaction. They don't take part directly in the chemical reaction, or they don't find or they don't form any particular compound in a chemical reaction, but the presence of this kind of a compounds brings the rate of reaction or a boost or increases the rate of reaction. That kind of a particular material is called as the catalyst. And catalyst is also playing a vital role in the chemical reaction or deciding the rate of chemical reaction. Now, another chemical reactions what we have to study is oxidation and reduction. Very much important type of a chemical reaction. The oxidation is nothing but the addition of the oxygen or the removal of the hydrogen. That particular kind of chemical reactions are called as the oxidation. You can see they have given the example over here, the magnesium reacting with the oxygen and forming a magnesium oxide. Here magnesium hydride, that is MgH2, is releasing hydrogen gas. So these kind of reactions are called as the oxidation. The chemical reaction in which reactants combine with oxygen or loses hydrogen to form the product is called oxidation reaction. Further, the next when we talk about is nothing but the reduction reaction. Reduction reaction is nothing but where the chemical reaction is losing the oxygen or adding a hydrogen. That kind of a chemical reactions are called as the reduction reaction. Another reaction we have, that is a redox reaction, where reduction and oxidations are taking place simultaneously. In a particular chemical reaction, if oxidation and reduction is taking place simultaneously, then the particular reaction is called as the redox reaction. Here the word redox is nothing but is a combination of two words. Red is for reduction and ox is for oxidation. So this reduction and oxidation, when they are present in a same single reaction, then that particular reaction is called as a redox reaction. Further, when we talk about the redox reaction, you can see they have given the example over here. H2S is reacting with the SO2. Here, sulfur dioxide is losing the oxygen, means it is a reduction reaction, and H2S is gaining the oxygen, hydrogen. That's why it is an example of a redox reaction. Further is when we talk about the further part in this, then the next what we have to study is the corrosion. Corrosion is nothing but a type or the chemical reaction, or it is due to the chemical reaction in the nature. For that, you can see here they have taken a 4 test tubes. First one is a oil layer on boiled water, second one is a salt solution, third one is a air, and the fourth one is a air and anhydrous calcium chloride. Now here this all the 4 test tubes what we have is a 4 different conditions maintained in them. The first one is a oil layer on boiled water. In this case, what happened when we boil the water, then the excess amount of oxygen leaving the water, and when we place the oil at the top layer, then it protects it from the external oxygen to enter in a water. So due to that, what happened when oxygen is not present in the water, the excess amount or the nascent oxygen, if it is not present in the water, then the oxidation of iron is not possible. So due to that, the iron which is kept in the boiled water covered with oil is not going under the process of oxidation, or it is very slow process. Another one is a salt. If salt is present, then the corrosion or the oxidation of iron takes place faster. Another one is the air. In the air, if there is a presence of a moisture, oxygen is already there in the air, then the oxidation of the iron is much faster. And the another one is the air and anhydrous calcium chloride. Anhydrous calcium chloride means in which the water molecule is not there, and this kind of the anhydrous calcium chloride, it absorbs water from the particular air and it reduces the amount of oxygen present in the air inside the test tube, and due to that the oxidation of the iron is not possible. Here you can see they have given the reaction. Fe is oxidized to Fe2 plus in the anode region, and O2 is reduced to form water in the cathode region, that is O2 plus 4H plus gives you the water molecule. Further, about the rust, they have given a reddish colored hydrated oxide is formed from Fe3 plus ion. It is called rust and it collects on the surface, and you can see here the formula they have given for it. So this is about the corrosion. The next one is the rancidity, the last part of the chapter. It's very simple. When we use old or leftover cooking oil for making food stuff, it is found to have a foul odor called rancidity. The smell of that oil is nothing but the rancidity. If food is cooked in such oil, its taste also changes. When oil or a ghee is left aside for a long time, or fried food is left aside for a long time, it undergoes air oxidation and becomes rancid. Rancidity in the food stuff cooked in oil or a ghee is prevented by using antioxidants. The process of oxidation reaction of a food stuff can also be slowed down by storing it in an airtight container. Simply, like in a market, what the fried food products we are getting, especially the chips or the wafers, you might have seen or you might have observed it. When we open the pack of that and we keep it for 1 hour or 2 hours or a day, then the taste of that changes. Why this is happening because that particular food packets what we are getting, the fried food packets what we are having in the market, they are filled with the nitrogen gas inside. So as soon as we open it, that gas leaves it, gas goes out, and then the oxidation of the oil present in that starts, and that make that particular oil rancid, and the foul smell start to come out after a few days or few hours. So this is about your chapter chemical reactions and equations.